You are watching College Education Tutorial, your number one knowledge center where complex topics in engineering and mathematics are simplified. My name is Noah Adasi, and today we are solving some examples of volume of revolution. Today's example is going to be simple. That is, we are going to solve some example in which the axis of rotation or the axis of revolution is going to be the x-axis. That is, someone can say y equal to 0, right? So let's go ahead and then solve the example. So for this example, we have only one function and we have been given the limit, which is x equal to 0 to x equal to 2, and the question is asking us to revolve it above the x-axis. So in such cases, what you have to do here is that, first of all, you have to do a rough sketch of the function that you are working with. So how can you do a rough sketch of that? Let's quickly look at the function. The function is y equal to square root of what? X. That's the function that currently we have. So how can we graph y equal to square root of x? Before we do that, let me quickly remind you of some of the stuff that you have learned some time ago. You know that if you are asked to do y equal to x squared, you know that it's simple, right? You quickly have to find the turning points, and then after finding the turning points, you know that this is what a minimum graph, right? Because the coefficient of what the highest power, which s squared, is what positive. In that case, is a minimum graph which will have the shape of what, something like this. Is that okay? So this is the one thing that we know, and assuming that we have the coefficient of x squared to be negative like this, you know that we have a maximum graph of which is going to have a shape like this. Is that okay? Yes. So in this case, we don't have it that way, but we have what? Y equal to square root of x. So I want to let you know that as we have a minimum graph and then we also have a maximum graph, which is also a parabola, we can also have a graph which either opens right to that of the x-axis or what opens left to that of the x-axis, right? So such graph will have a behavior like either this, open to the left, or open to the right, right? That's how the behavior of such graph will be. So how can we do that? We can do that if the graph is in terms of y. As you can see over here, the graph here is in terms of x, right? And in such cases, we either have this or we have this, depending on the nature of the function that will be given to you. So given the fact that we have been given y equal to square root of x, then we can go ahead and say that, okay, I can simplify this. Why don't I have find square of both sides like this? So the square here will cancel what? The square root here, and then I'll have what? X equal to y squared. Now I have the function in terms of what? Y. In that case, let's do the same thing as we did for this function. For example, this here, if the coefficient, as I was saying, if the coefficient is what? Positive, we have a minimum graph, right? If the coefficient is what? Negative, then we have a maximum graph. So looking at this one, if the coefficient is positive, the graph opens to the right like this. And if the coefficient is negative, that means the graph opens to the left like this. So in such case, what we can do is that when we have the turning point, that is when we differentiate it with respect to y, that is the x dy, we will have the turning point to be 0, 0. It means that the turning point, or the point at which it's supposed to turn, will be what? 0. Is that okay? So based on that, we will have to do that. But you have to also take note that we are only considering the positive side. We are only considering the positive side of it. So in such case, what we are going to do is that we are going to do something like we have our graph here, and then we have, let's say, our graph here. Yes. So having this graph here, what we can do next is that we know that the turning point, it's at the point 0, and we know that it will open to what? To the right. In such case, we can draw it this way, right? So let me extend this small. Yes, so this way, that means if I am to kind of add this part, it will be like this, but that is not of importance to me, so we ignore that part. After all, when you revolve it, you see how it will look like. So now this is how my graph will be like. I am not adding this part because All values of y will be positive. Whenever we put any values of x, that makes the function y equal to square root of x defined. So in that case, we are not considering that aspect, the negative part of y, the function. So let me clean it over here. So now that we have some simple sketch over here, we know that we have been given from x to 0 to 2. So we can indicate here is 0, and then we can also indicate here as what? 2. Is that okay? So now that we have this one, if we revolve this curve above the x-axis, we are supposed to get a curve like this. Don't forget that it is symmetrical about the axis of rotation or revolution, right? So in such case, this is what we have. So this is actually the figure that we are going to find the volume of revolution. Is that okay? Up to the limit, which is 2. So now that we have this, we are going to use the Dix method. So in using the Dix method, what do we do? As we were explaining earlier on, we said that we have to approximate this one in into a circular Dix form. And in doing that, we approximate it by using the area of a circle, because the Dix is a circular Dix. So in such cases, we are going to do, okay, A equal to pi r squared. That is the area of a circle. And last time I showed you how you'll be able to find the radius of this figure. And I was telling you that the radius of this figure, because it's symmetrical, the radius of this figure starts from the axis of rotation to the points of the graph, and that's we trace it to the corresponding y value, and that will give us the equivalent distance from the axis of rotation. In this case, it's y equal to 0. That is the x-axis to the graph, and then we get a y value of it. So in that case, we'll be able to estimate the radius. And when we do that, we will have to put the x value at that instance into the function's value. That's where we're able to come out with a equal to pi. And then the function value here, right? The function value here is we can make it in a different way. The function value here is let's say square root of x. And don't forget that the radius is square. Is that okay? So based on that, this one will automatically cancel this one out, and then we get a to be equal to pi and then x. And therefore, since you have been given the distance from the limit from 0 to 2, what we are going to do here is that we do the integral of pi x dx, and the limit is from 0 to 2. So when you get here, the next thing that you have to do is to integrate the function that you have. So now we have the volume to be equal to the integral of the area, which is integral from 0 to 2 of pi x dx. So in that case, we have the volume to be equal to, so now when you integrate this, we are going to get pi x squared over 2. Is that okay? So in such cases, we have the limit from 0 to 2. And it's just a matter of putting everything inside. So when I do this, I'm going to get pi out. I'm going to get 2 squared over 2, right? And then minus 0 over 2 as well. That is 0 squared over 2. So in such cases, we have pi multiplying by 2. And then you know that automatically here is going to 0. Therefore, we are going to get 2 pi. Is that okay? So basically, this is how we do things. I believe that when you get here, when you get to this side, then the rest become easy, because the rest is the normal integration that you know. The only thing that you have to do here is to know how to do a simple sketch of the function that you have been given, and then we are lucky that we have been given our limits of integration, and based on that, we can employ the area approximation for the Dix, and we will integrate over the area with respect to the variable that we are working with, and it will help us to find the volume of revolution for that particular curve. You can see in the sketching, someone can also decide to do in a different way. The person may not pass through the approach that I was using earlier on by comparing it to what we know already, right? Someone can also decide, okay, if I have y equal to square root of x, then how am I going to deal with it? So having y equal to square root of x, the person can say, okay, square root of 0 will give us 0, right? That means it will pass through the middle here, right? And then the person goes, okay, square root of 1 will give me 1. So if I have 1 here, that means square root of 1, that means to pass here. Then square root of 2, the value will also, let's say, give us here. Square root of 3 is give us here, and so on and so forth, right? So in that case, you'll be able to come out with this particular shape. However, if you are also comfortable with using the simple analysis that I was doing to kind of draw what it's showing here, then that one is okay. Yes, the only thing is to be able to draw it, at least do a simple hand sketch, and then kind of get whatever you want. Yes. So our next question is showing over there, and as you can see on the screen, it's what rotate the area between y equal to x and then y equal to square root of x from the boundaries, which is x equal to 0 to x equal to 1, around the x-axis. So our previous question, we were rotating only one function, that is y equal to square root of x. But in this question, we are rotating our two functions. That means we have to do a simple hand sketch for these two functions, and then we proceed with the revolution, right? So for this type of question, note that we are revolving around that same x-axis, that is what y equal to 0. So for this type of question where you have to do a simple hand sketch for what? Your two functions, this is what you can do. The first thing that you can do is to find what the point at which the two functions are what meeting, right? But we are lucky. Some questions are there, they will not give you all the boundaries, but for this question we have been given the boundaries, and therefore there's no need for us to find the meeting points, right? So in such cases we don't have to find the meeting point. But in cases whereby we are not given the boundaries, which is x equal to 0 and x equal to 1, that means that we have to find out the boundaries, or that means the point at which they are meeting. So kindly check the next tutorial to continue solving this question. So thank you for watching, and see you in my next video.